Mm. Hello, my name is Angel Arana, and this presentation I'm going to be talking about three different focus sequences within structural engineering, including civil structures, aerospace structures, and geotechnical engineering, each of which plays a huge role in how structures are designed, built, and analyzed. I'm going to be explaining what each area does, the kinds of problems they solve, and why they're important. At the end, I will be talking about which focus I plan to pursue and why it fits my interest. Starting with civil structural structures. This is one of the most central parts of structural engineers, and since most of their infrastructure includes things that are directly focused with everyday people lives. This includes buildings, bridges, stadiums, towers, and other things that people use every day. This engineering field focuses heavily on making sure structures can safely resist gravity loads, winds, temperature changes, and especially earthquakes. Since we live in California, seismic design is a major part of civil engineering. Analyze how forces travel through beams, columns, walls, and foundations. Common problems civil structural engineers um, face are how strong does this beam or column need to be? How will this building respond during an earthquake? How do we design a structure that's safe but also cost effective? Next up, we have aerospace structures. This applies to structural engineering and principles to aircraft, rockets, spacecraft, and satellites. These structures are very different from buildings since they need to be extremely strong but also as light as possible. Reducing weight is one of the most critical parts of this sequence. Aerospace structures experience loads like aerodynamic pressure, turbulence, engine vibrations, temperature extremes, and fatigue from repeated flight cycles. Some problems that aerospace engineers may come across include how much load will this wing experience during takeoff or turbulence? How will fuselage panel buckle under compression? And how do composite materials behave under repeated loading? Next up is geotechnical engineering. This engineering deals with soil, rock, and the ground that all structures rely on. Even the strongest building can fail if the soil underneath isn't properly understood. Geotechnical engineers study the properties of different soils, how they behave under loads, and how environmental factors can affect stability over time. Some common problems that geotechnical engineers can come across include how much will this building settle over time? Is the soil strong enough to support this load? Is there a risk of landslides or liquefaction in an earthquake? Do we need a retaining walls or slope stabilization systems? Geotechnical engineering is essential because every structure depends on the ground. A building is only as strong as what it sits on. As for my focus is I would prefer to be in civil structures. Um, I like this focus because it has a direct impact on the built environment that people use every day. There's something very meaningful about designing a structure that thousands of people could live in or work in every single day. I'm especially interested in the seismic engineering side of civil structures because of California's strict safety requirements. I enjoy learning about how buildings resist earthquakes through shear walls, moment frames, and other lateral systems.